welcome back to part 3 of the radar robot, and let's continue with our series here. So we're going to have a demo and have a look at some code. So let me jump over, I'm just going to put it onto me for a second. I'm going to jump over to Thonny and we're going to load up the code. So let's just jump over here first of all. So this is the code I've written. So I've got 3 different pieces of code that I'm going to show you today. I've got the Rangefinder, which is simply that code that you saw on screen a minute ago. I put it into a class so we can basically just reuse this many times. And we can by putting it as an @ property decorator on the top of our code, we don't need to use brackets. We can just say rangefinder.distance and it will return the distance. So we can see there. And I've also used this round function, which just gets rid of all those decimal points that you sometimes get with floating point numbers. And I basically just said, give me 1 decimal point. We're measuring things quite crudely. We can measure them in millimeters and or centimeters. This one returns in centimeters. That's why I'm dividing the millimeters by 10 to get the centimeters. And I'm also rounding that up to 1 decimal point, just because it makes sense to have it with that granularity. So there you go, returns in centimeters. So I'm going to use that rangefinder function. I do need to make sure that rangefinder code is uploaded. So I need to do upload to, and then I've already got it on my Pico here. So if we go to our radar code, this one is just going to make it sweep round and display on the display all the different readings. So let me just talk you through this. So we're importing servo. Remember, I'm using the Pimroni Pico MicroPython build. So it has things like the servo class built in, and it also has Pico graphics built in, which we'll use in a minute. We're going to import time because we need to use the sleep function quite a bit. I'm going to import the rangefinder object, the class that we've just seen a second ago. I'm going to set my trigger pin to 2 and my echo pin to 3. I'm going to write out all the readings that I take to a data file. And the reason that I want to do this is I'm going to train my neural network over next week to recognize different objects. And to do that, I need to have a text file, a CSV file, comma separated values file with all the different readings. So one for each of the degrees that it sweeps round. I can then feed that into the neural network and say, this particular scan had a Coke can in front of it. And I can classify all those things. This one has a chihuahua in front of it, and take a couple of 100 readings for each type of thing I want to see. And then I can feed that into the neural network, and we'll have a look at how to do that in a future video. The next 2 things, so I've got S, which is our servo. So I'm going to start it off on being pin 0. Remember when I was saying which pins I've got this connected to? So that's GPIO 0 on this particular one. And I've got the rangefinder there. I'm just setting up the trigger pin is GPIO 2 and echo pin is GPIO 3. So I just need to remember that when I'm plugging this in. Let me just make that adjustment on there for when we do our radar in a second. Okay, so then we're going to I've got a function here for take reading. So I've got an array that's called readings, and I say with open data file, and we're going to append to this file, and it's a binary file. So we then basically just say for I in range 0 to 90. So we're going to start in the middle, and we're going to go, which way would it be? To the right, perhaps? It depends which orientation the servo is. And then we're going to basically just loop around there 90 times. We're going to set the servo to whatever the current I is, which is the degree we're sweeping through. We're going to print out to the terminal what the distance to the current object is, what the angle we're currently sweeping around at, and what the count is as well. I think I use count. Where do I use count on there? I'm not sure what I've used that for. Okay, and then next is basically going from the 90 position back all the way across to -90. So the way that these servos work is they have a center position, the sort of middle position. So say that's straight up, and then you can go -90 or +90 for the whole 180 degrees. You don't start at 0 and go all the way 180. So I just need to factor that in when I'm doing my code on here. So then we go all the way between 90 and -90, stepping -1 at a time. You can see there we don't include 1 to say step 1 thing at a time, increment in the for loop in steps of -1, and then we basically sweep all the way back. I've got that sleep as 0.01 seconds, so it's really, really quick. And then after I've taken a full 180 degree sweep, I'm going to write the contents to a file. So there we go. The count That's what the count is for. The count is just to tell me how many times I've taken a reading and written it to the file. I think that's what the intention of that was. I can't see where I increment that though, so I must do that. Must do that somewhere else. Okay, so what we do next is we print out, wrote the data file, and then we just return the servo back to the middle position. Now the reason I do this is I found if I try and make the servo move really quickly, particularly with these sort of high quality ones, I think they draw a bit too much power from the Pico, so it probably just pulls more than 5 volts, or the current that's going through it is a bit more than the Pico is happy with, so it cuts out the and reboots the Pico. So what I've done is if I just move that back, it doesn't do that quick sweep back, it does this sort of gentle one. So that's what that last piece of code there does. I then got a demo one, which is just when I was trying this out, I was just getting it to sweep round and print out to the terminal. And I had another one called sweep, where you could basically just say, here's the servo, here's the rangefinder, and just give me some readings back from that. So the for loop is very, very simple. I've commented out all the other stuff there. This is where count comes in. We say for count in range 1, and in steps of 2, take the readings, and then sleep for 1/4 of a second. So let's get over to our overhead camera. Let's just bring this robot into view there. And what I'm going to do is I'm going to run this code. I'm just going to bring it up to there and just watch the terminal and watch the robot itself. There we go. So it's sweeping round, and you can see the count is currently at 1. And when it goes back to the middle position, that count should go to 2. I've actually got the loop so that it only actually takes 1 reading currently. So if we just do that to say, let's say count in range 1 to 2, so let's change that to 10 and then run it again. We'll get it to do 10 sweeps. There we go. So we can see the distance there is in centimeters. So yeah, about 30 centimeters in front of my desk is a wall. If I put a object in front of it like so, you can now see that some of the readings will say 6 point something. I'll tell you when it's pointing at it. So it's pointing out now. There you go, 8 centimeters away. And we can see what the angle is as well in degrees. So what you're probably looking for though is where's that nice radar thing that you've talked about? So let's have a look at that next. So you can currently see I haven't got a display on the back of my robot currently. What I have got is this Pimoroni Pico Explorer base. So this is a really nice, I've just got some blue tack on there to keep it in place while we're looking at it. So if I just move that up, let's plug that into place there. Okay. Let me just move the microphone over here. So I just need to sort of plug in some bits and bobs. I'm just going to have to unplug that wheel for a second. Plug that into this Pico down here. The right orientation. There we go. And let me just put that in place. And I'm also going to have to pull out our rangefinder and have this plug in from here instead. So let me just grab my robot. Let me just make sure I've got this right. So the yellow should be the 3.3 volts. The blue should be, sorry, the green should be the ground. We've got the blue as the trigger, and the purple one is the echo. It's a bit of a fiddly thing to do this on camera, but let me just mangle these for a second. So that's going there. What did I say the trigger was? Blue. That's the main one. There we go. And then the purple one is the echo, and the green is the ground. Right, we just push these into place. Okay, now you can see that I've not actually got the servo hooked up on this Pico Explorer, because there's nowhere on this to get 5 volts from, so I'm a bit stuck at the moment on this particular one. But we can actually try out our scanning thing without spinning this round, or we can spin it manually to see. So I'm just going to point it at that Diet Pepsi can there. I'm going to come back over here, and what I'm going to do, I'm going to load up my radar display code. I was fiddling with this before, so hopefully I've not ruined it. And let me run the script and let's see what happens. Right. So you can't currently see the Pico display, so there we go. So we've got the radar scanning. So So if I put something in front of the radar, and what I'll do, I'll zoom in a little bit as well so you can see this. Let's get this into position so we can see what's going on. There we go. So as it's taking readings, if I put some things in front of it, not my arm, we can see that the range changes. So there we go. If I put my hand in front of it, so I've got my hand in front of it now, it's changing it slightly. And if I remove my hand, you can see there that the scan has changed colour. So the radar is working. What I haven't got working both together, just because I've run out of pins and power, is the actual sweep of the servo and the radar working in unison. But it's very simple to do that. I have got the code to do that. In fact, this code is actually supplying the correct instructions to have the radar work. So we can have a look at the code of that and just see how different it is. So let me just stop that from running for a second. I did say this is a multi-part video, so we will come back to this and we'll have all the parts working. I've ordered the little display, which is the exact same display that we've got here, but as a breakout garden display. We're going to have that on the back of the robot so we can see the scan on the robot and it'll be self-powered. Okay, so let's have a look at the code. Let's go to this view and let's have a look how this is actually working. So I'm importing Pico graphics first of all. Like I said, I'm using the Pimoroni Pico graphics library and the version of MicroPython. The batteries included MicroPython. So let me just show you how we can do that. If I go down here and I type import machine and I do machine.bootloader, like so, it'll put you can see there it's dropped out and it can't connect to the Pico. If I click on here and I go to configure interpreter, we can now flash the firmware by going to install, and it recognizes there. We can say what MicroPython variant do we want, and we can select this 29 different variants of this, and I want the Pimoroni. Let me find it. I think it's down there. We go. Pimoroni Pico, it's either a Pico or Pico W, whichever you've got. I've got the Pico W H and version 19, so I can click on install. It'll then install the software and we can copy our Rangefinder Pi to that and then start again. So if we wanted to load CircuitPython, we could just use the exact same method. And I believe it works exactly the same whether you have a Mac, PC or Linux. So let's just click OK on that. I'll click down on the bottom here, and yeah, we're using Raspberry Pi Pico and using MicroPython. So there we go. Because I've not flashed the RAM, it can actually still see in its file system that rangefinder.py is still there, and there's even like that readings.csv. I'm not sure if, yeah, there we go. Got a couple of readings that we took and we've been building up, so it'll keep adding to that if I run that radar.py. So let's go back to our radar display. So we're importing the Pico graphics, and I can even tell it what kind of display, because it's a Pico, because it's a Pimoroni product. They've already classified all their different displays as a constant there. So display Pico Explorer, we can import that, and then we can set it up down here by saying display equals Pico graphics, Pico display Pico Explorer, and we can even set the rotation of the screen. So depending how we have our screen mounted, we can very simply just change the rotation degrees in there, like 90, 270, 180, and it'll be the correct orientation for however we have that mounted. Some of the things we have in here, so we have I use GC, which is the garbage collection. This is simply because we're doing some stuff with memory. We're putting things into arrays, and because we're doing that many times, I thought let's just include the garbage collection thing in there. We'll probably run that a few times, excuse me, further down in our code. We're using the maths library, so we're bringing in sin and radians, bringing in time and sleep, we're bringing in our rangefinder library that we created earlier, we're bringing in machine and pin, and the servo library as well, which is a Pimoroni MicroPython. I included the motor code there, but we don't actually use it. That was me trying to hack the Pico Explorer to get 5 volts, because I'm sure the motors are 5 volts output, but that didn't work, so ignore that. You can basically just ignore these 4 lines of code there. Then the trigger, we're just setting the trigger on the echo pins like we did before. We're setting S and R to be the servo on GPIO 0. We're setting up the rangefinder to have the trigger and echo pins. Now the display, we're creating a new object called a display using Pico graphics, using the Pico Explorer display. we can get the width and the height of the display by doing display.getBounds. The next section here, we need to create something called a pen when we use Pico graphics. Whatever the current pen color is, when you do a graphics instruction, like line, whatever the current color is, that's what the pen will draw. So I've set up 5 different colors there. Really dark green. So this is red. The red are, so it's RGB values. The red is 0. The green is 64. The blue is 0. Dark green is 128 for the green. Everything else is 0. Green is 255, so the highest green value. Light green is, that's white at the moment. I think I tried having that as like 128 and 128, so it's like a really washed out white colour. And black is basically just everything is 0. So then to create a pen, we bring in the current display object, because we need to set the pen with that, or create a pen. We then bring in whichever colour we're passing in, and the colours are always going to be in this format where they have a list. They have a dictionary. They have a dictionary. A dictionary has 2 values, a key and a value, key and a value, key and a value. So this is a dictionary, and we've got 3 things in our dictionary to choose from, red, green and blue. And then once I've created these red, green and blue things with the values, I then want to create the pens themselves and have those stored. So black equals create pen, display black. Green is create pen, display green, and so on. So we've got those 5 pens to be able to use in our code later on. And I want to define the length of our line as being whatever the width of the display is, divide that by 2, and that means we can get a nice sweep round the full width of the display. And that the middle is the width of the display divided by 2. And again, the reason I'm using these double slashes is if you, let me just go down here and show you this. If I have a number, so let's say 240, let's do A equals 240. And then let's say B equals 240 divided by 3. Let's just do an awkward number. Let's look at B. So it's 80.0. Let's try 5. See what B looks like then. 48. I'm trying to find an unusual number. Let's do 7. Yeah, 70. There we go. So if I divide that by 7, for example, I get a floating point number 34.28571. Now that's not good if we're using a pixel display. We want absolute whole number values. So if I do double slash like this, and I now check B, it'll be a whole number. It basically just gets rid of all the floating point parts and just has an integer. So it's a really nice way to just deal with integers. So that's why I use the double slashes there. We're setting our current angle to be 0, so it'll be, we're sweeping from 180 throughout 180 degrees, starting at 0, with 0 being flat. But remember, our servo is slightly different to that, so we'll have to add 90 degrees to whatever our servo is currently working at. But I've also included here, just in text, just to remind you what we're shooting for. So we need to solve an AAS triangle. The angle of C is 90 degrees. Oops, 90 degrees. We know what the angle A is because we're going to pass that in. And we know the length of side C because that's going to be our length, our 100 pixels, or if we've set it before, I think we said it was the width display divided by 2. And what we're going to do now then is just find what the angle B is, and then that means we can then work out the length of A and B, lowercase. So here's the formula for doing that. So capital A, that one is our main angle, we know what that is. That's what we're going to pass through the loop, 180 degrees. C is always going to be 90. So B is 180 minus C minus whatever our current angle is, and therefore we'll be able to calculate what that B is at the top there. The length of C we know is our length. So to work out lowercase a and b, we just need to use that C sin A and divided by sin C. And because they're in radians, we just have to put them in that radians wrapper as well. So there you go. And then to work out what x1, y1 is, so x1 is the middle of our display minus b. So if our display is like here, the very middle point of that, we want to use that as an offset and have b minus that so that it's in the correct place. Because we're using the, we're sweeping, I'm trying to sort of describe this with my hands. If my display is like that, where my thumbs touch is the middle point, our line is sweeping from that very middle point around 180 degrees. The y1 is whatever the height We just have to take off 1 pixel because displays start at 0, not 1. So we just need to take off whatever the height is, -1 to that. And then we minus A, which is the angle that we worked out, sorry, the side that we worked out before, which is this height here. So there we go. So Y is always a height, X is always like a length. And we know that X2 is the middle between my 2 thumbs there of our display, and the Y2 is the height, -1. So the height of the display, just -1 pixel there. Okay, so then we can return X1, Y1, X2 and Y2 from our little calculate vectors thing. And then we can do some stuff with our display. So we can say angle equals 1. The direction is true because I want it to sweep round and sweep back. I found that if I didn't sweep back nicely, the servo would just go zzz, all the way back to 0, and that would cause a spike on the Pico, and it would just reboot the Pico. So that's why I've got this direction thing, which is just, is it going forwards or is it going backwards? That's really all direction does. So we set our servo to whatever the current A value is. So A is currently 1, so our servo should be set to 1 degree. And then we set the distance equals to the whatever the rangefinder distance is currently, so is our rangefinder. And then we say if I've got 3 bits of code here, and they're just going to check if our angle is greater than 1 or 2. And this is how we get that trailing edge. So when we sweep round with our radar, we want it to leave behind some pixels so it looks like it's sort of fading. So we need to do that with a couple of different colours. So I've got really, really dark green, and then the main piece of code is our light green one down here. And what we're going to do is we're going to overwrite, we're going to draw a line, and then we're going to overwrite it with the length of the distance that we're detecting. So if we draw a solid white line and then we overwrite that with the distance from the very bottom to the top of the object that's in front of us, we can then basically erase that and just have that top bit be the really bright bit, which is where in our sweep we've detected what we're looking for. So these 3 pieces of code basically just do the same thing. They just say if A is greater than 1, or A is greater than 2, or A is greater than 3, we can then basically just offset the sweep that we're going round. So x1, y1, x2, y2 equals calculate vectors. We pass in the angle that we want to sweep round. I put in here plus 90 simply because we're using a servo as well. And I just wanted, I might take this out, but essentially that's just whichever angle. You could have that just as A, to be honest. It's probably better to do that actually. Like so. -1 just means whatever the current angle is, just go back 1 angle and then draw a really dark line on there. And that's a way of kind of erasing what we've currently done on our display, because our display will stay there and it's additive. Whatever you draw on it, any graphics operations you do, they are additive. So I just need to remember to break for part 3 in a second, Alex, so I shall do that after this one. So that's what A1, A greater than 1, A greater than 2 does. They basically just erase the sweep. And I had another one there for A greater than 3, and that would just erase everything and you wouldn't have any sort of sweep left over there. And then this is the main one that actually draws the bright thing on the screen, the object that it's detecting. So we do the calculate vectors again. We can have our angle that we are looping round 180 degrees, and I've actually set the length here to be 100. So I know before we said it was whatever the display divided by 2, but I found 100 worked better. We then set the pen color to be light green. We actually draw the line x1, y1, x2, y2, and it doesn't matter what the angle is or where you start from, it always works correctly, so that's nice and simple. And then we can then work out what the scan length is. So what I've done on here, depending on how far we can scan, and I found that if you have nothing in front of these rangefinders, it thinks it can scan up to 120 centimeters away. That's the absolute distance it thinks it can measure. So if it can't find anything, it returns 1200 millimeters. So I want to be able to set that and calibrate our display so the length of the objects on the display are calibrated to a distance that I choose. And I might not want 120, because if I detect something say 5 centimeters away and it can do 120, it'll be like 1 or 2 pixels on our scan, so we can actually calibrate how far our scan is searching. So this is what this scan length is. It's just a way of scaling that. So if the scan length is over 100, just make the scan length to be 100, and then we print out what this scan length is, and then we calculate the vectors again based on that scan length. We set the display to be green, and then we draw the line. Finally, after doing all those drawing operations, we then call display update, and that actually makes it appear on the display. If we did display to update after every single graphical operation, your display will flicker. So it's best just to do this once every loop round, and your display won't flicker then. And then I've got some code here depending on which direction the scan is going. So I want it to go scan forward and scan back. And that's mostly because the servo, if it flips back, it'll just reboot the Pico. So I'll just check to see, is it over 90 degrees? Is it less than 90 degrees? All that kind of stuff, because the servo works in plus minus 90 rather than 0 to 180. So I just need to factor that in, and that's why I had that plus 90 in the code up here, which I can put back in now. So there we go. So the next step will be to get the display and the servo working in unison, so it actually works in the way that you probably expect it to. But that's the code. It's actually quite simple. How many lines is that? 120 lines of code. Very simple to do. And that's it for the show today on the replay version of the show. So if you're watching this on replay, this is the point in the video where I'll say thank you so much for watching. I hope you've enjoyed this part of the video and the other 3 parts as well, and I shall see you next time.